Hi, ladies and gentlemen. We are looking at notes 12.4, which are on systems of equations. You guys already know how to solve systems of equations, but only if they are two linear functions. Now we're going to learn what to do if we don't have two linear functions. So in order to solve a system of equations graphically, doesn't matter what type of a graph it is, all you have to do is graph them all out and see where they intersect with each other. They could be linear, they could be quadratic, they could be exponential. They could be any type of function, and you could have a mix and match of any of the functions as well, and they will still intersect with each other. They could still potentially intersect with each other and have a solution. All right, so the first thing we're going to want to do is identify what type of functions we have here. Well, our first one is in the form ax squared plus bx plus c, which means that it's going to be a quadratic function, all right? And then our second one is in the format y equals negative 2x plus 3, y equals mx plus b, so it's linear. So let's deal with our quadratic function first because that's a lot easier to deal with. And what I'm going to do for my quadratic function is I'm going to create a chart so that I can graph it out. Or I could write it in vertex form and go from there. Once I write it in vertex form, I can figure out how to transform the function. So since we're doing transformations of functions in this unit, we're going to use that method. But if you want to create a chart by finding the axis of symmetry and going from there, that is absolutely fine as well. So what I'm going to do is I'm going to make sure that my a value is positive 1, which it is. So in order to complete the square, I'm going to take my b value, divide it by 2, and then square it. So I get negative 3 squared, which is positive 9. So then when I do this, I end up getting y equals x squared minus 6x. I can add the 9 right here, right? And then add the 3, bring it down, and then to make up for the fact that I added 9, I'm going to subtract 9, okay? So then my new function, not my new function, but my new format will be y equals x minus 3, quantity squared, minus 6. All right, so for this one right here, I already know what my parent function will look like for a quadratic graph. I know that my points are negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. So then when I connect my dots, this is what my parent graph will look like. Now to graph out this new graph, I know that all I have to do is shift it because it's only subtraction right here. There's no multiplication. So I'm going to shift each point 3 units right and down 6 units. So again, each point just goes 3 units to the right. So 1, 2, 3. Let me just change this really quickly so it's a little bit easier to see. So 3 units to the right, 1, 2, 3, and then down 6, 1, 2, 3, 4, 5, 6. So that's where my new point will be, okay? So again, I'm going to go 3 units to the right and down 6, and that's where my new point is. Here I'm going to go 3 units to the right, 1, 2, 3, down 6, 1, 2, 3, 4, 5, 6. That's where I end up. Next one, I'm going to go 3 units to the right, 1, 2, 3, 6 down, 1, 2, 3, 4, 5, 6. I'm at my vertex of 3, negative 6, which is should make sense to you because that's what this equation says right here. Here I'm going to go 3 units to the right, 1, 2, 3, and down 6, 1, 2, 3, 4, 5, 6. And then lastly, for this one right here, 3 units to the right, 1, 2, 3, down 6, 1, 2, 3, 4, 5, 6. This is where my new parabola is. So I'm going to delete or erase my first one because I don't need it with my system. And I'm going to graph out my new parabola. So here's where my new parabola will be right here. Okay. All right, so now I need to graph out my linear function. Well, my linear function, all I have to do is figure out what my y-intercept is, which is 3, and then I'm going to go down 2 and to the right 1, okay? So again, all I have to do is figure out my slope and then go from there. So start at 3, go down 2 to the right 1, down 2 and to the right 1, down 2 and to the right 1, down 2 to the right 1, down 2 and to the right 1. If you notice, when we did our systems of equations before, we had our 2 lines would intersect either 1 time, 0 times, or infinite times if they were the same line, right? However, now we have a parabola and a quadratic function. And since we have a parabola and a quadratic function, they could intersect up to 2 times. And here's a perfect example where they intersected 2 times. But we don't have our second value. We know for sure they intersected here. Our second equation, or our second intersection point, however, we're not 100% sure about because we didn't actually have a point right here for our parabola. So I'm going to figure out and see if it really works when x equals 0. So y equals 0 minus 3 quantity squared minus 6. All I'm doing right now is I'm just plugging it into my function. So I get negative 3 squared minus 6. So I end up getting 9 minus 6, which is 3. So 0, 3 is a point on my parabola. So then when I do this right here, I'm going to write out my final answer. My final answer is where my 2 points will intersect with each other. And those 2 points intersect with each other at 0, 3 and at 4, negative 5. So those are my 2 answers. And since it's a set of answers, I've got a solution set, and I'm good to go for that question. All right, so let's take a look at question number 2. It says, solve the following system of equations algebraically, and it's the exact same question as we had in number 1. So our answers should be the same. But how do we do this algebraically? How do we solve this on paper? By the way, the only ones that I'll ever ask you to solve algebraically are systems of quadratic linear functions or 2 linear functions, okay? So to do this algebraically, you will have, this is a quadratic function, and then this one right here is our linear function, but the process is still the same. We're going to use substitution. Elimination is a little bit trickier for this type of a problem. We could still do it, but substitution is so much easier. And if you notice, this y is already by itself, so every time I see a y right here, I can replace it. I can just plug in negative 2x plus 3 instead of y. So I get negative 2x plus 3 is equal to x squared minus 6x plus 3. And I'm going to get everything on the side that will make my a value positive. So I'm going to add 2x and subtract 3 from both sides. So you end up getting 0 equals x squared. When I add 2x to negative 6x, I get negative 4x. And then when I subtract 3 from 3, I get 0. So now I have to solve this problem right here, just like you learned how to solve in the quadratic equations unit. Don't forget your equals 0. The first question you're going to ask yourself is, can I factor it? And if I can factor it, the first question I ask myself there is it factorable by GCF? And yes, it is. So I'm going to factor out an x, and then I've got x minus 4 left over, and it's super easy to deal with now. So now that means that my two x values are x equals 0 and x equals 4. All right? But remember, when you solve it, there are 2 variables in your problem right here. We've got x, and we also have y. So now we have to figure out what are our corresponding y values. And you can use either equation to figure this out. If I were you, I'd use the easier one. So the easier equation would probably be the linear equation. So y equals negative 2x plus 3. Every time I see an x, I'm going to replace it with the number 0. And then I'm going to add 3 to it. So I get y equals 0 plus 3. So you get y equals 3. So that means that my first coordinate where it intersects is when x is 0 and when y is 3. So that's my first coordinate. Now to figure out the second coordinate, instead of plugging in 0 for x, I'm going to plug in 4 for x. So I'm going to say y equals negative 2 times 4, and then plus, oops, sorry, excuse me, this should be a 3 right here. Sorry about that. Plus 3, so we get y equals negative 8 plus 3. So I end up getting y equals negative 5. So the second place where it intersects is at 4, negative 5. So then our 2 answers will be 0, 3, and 4, negative 5. And that's what we got when we solved this by graphing, okay? All right, so question number 3 is more of a challenge problem. We haven't really learned how to graph this equation out yet, and you won't learn how to graph this out until you are in geometry, but just so that you know, it's going to end up looking like a circle, and it's not even a function because remember, circles don't pass the vertical line test. So this is not a function. but we're still going to solve this system of equations. So the first thing I'm going to do is I'm going to isolate a variable, and I'm going to choose the easiest variable to isolate. And to do that, I want to look at the equation that has the easiest variable to isolate, which is my linear equation. The circle equation is a lot more difficult. So in order to solve for a variable, I have to decide which one I want. It doesn't matter. You can solve for x or y. So let's solve for y. Totally up to you. So if I were to solve for y, I would subtract x from both sides, so I've got 1 minus x. All right? So now, every time I see a y right here, I'm going to replace it. So let's go ahead and do that. So right here, what this is going to look like, I'm going to just write the problem down. X minus 2 quantity squared plus y minus 1 quantity squared equals 4. And x minus 2 is going to stay the same plus, and then instead of this y right here, I'm going to replace it with 1 minus x. And then I'm going to copy the rest of the problem down exactly how I see it. Minus 1 squared equals 4. All right, so then this ends up being x minus 2 squared plus this one and this negative one cancel each other out, so plus x squared equals 4. So then I'm going to go ahead and distribute all of this through. At this point in time, you should be okay with me just saying that it's x squared minus 4x plus 4. I don't really have to do much more. Plus x squared equals 4. Combine your like terms. We got x squared plus x squared is 2x squared. Minus 4x, just copy it down, plus 4, so that's where all of this stuff came from, equals 4. Now, just get everything on one side. You end up getting 2x squared minus 4x. When you subtract 4 over here, it cancels the 4 over here, so you get equals 0. I'm going to try to see if I can factor this, and there is a GCF. So I'm going to factor out my GCF of 2x, and then I've got x minus 2 left over. So that means that my two x values where my circle and my line intersect are x equals 0 and x equals 2. And it should make sense to you that you got two x values because when you graph out a circle and you graph out a line, the maximum number of times that they can intersect with each other is twice. So it's possible that you could get two different answers. But now I have to figure out, well, what are my corresponding y values? So let's use the easier equation to figure this out. X plus y equals 1, I believe. Yep, so x plus y equals 1. So instead of x, I'm going to replace it with a 0. So I get 0 plus y equals 1, which means that y equals 1. So one point where my two graphs intersect is when x is 0 and y is 1. All right, and then I'm going to do the same thing for this one right here. So every time I see an x, I'm going to replace it with a 2. So I'm going to say 2 plus y equals 1. So that means that y equals negative 1. So my second answer is 2, negative 1. And that's the set of my solution to my system of equations.